Okay. And the question says, is a solution of lithium, blah, 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 acidic, basic, or neutral? And what is the predominant hydrolysis reaction? Do you think you could do it? It's okay if you say no. I'm happy to go through it with you. Kind of, yeah. And it's okay if you are like, yes, we can do this. Do you want to give it a try? Yeah, give it a try. Yeah, you start with separating. If you don't know where to start by separating the ions. So if you don't know where to start, you can start with the dissociation, or you can just in your head say, I'm going to separate it in my head into Li plus and H2C6H7 minus. Second thing you do is you check and see if each of the ions hydrolyzes. Does Li plus hydrolyze? It's a cation. Are there lots of cations that hydrolyze or not very many? Not very many. Who are the only ones that do? FeAl, Cr, feel creepy, and NH4. Okay, so the answer is no, because it's not one of those. And anytime you have an anion, you should ask yourself, is the anion amphiprotic? Is it? Yes. It has an H plus, and it has a negative charge. If it's amphiprotic, you have to do donating a proton and you have to do accepting a proton. So you'll want to do both the acid process and the base process. If it's acting as an acid, what would we get as our product? HC6H5O7, and the charge would be 2 minus, and we have H3O plus. And we're also going to do the base, because this is an amphiprotic ion, and it's going to accept H plus. Oops, I'm just rewriting what was above. What should I get? I should get H3. C6H5O7. Does it have a charge? No. So this ion, some of those ions are producing hydronium and some of them are producing hydroxide. The question then becomes, what does the question become? Which one produces more? How do we tell which one happens more? We compare the Ka and the Kb. So we are going to find the Ka of, and I would always put in brackets what the species is because you got a lot of chemical species floating around here. So I would just be very specific. It's H2C6H5O7. And the Ka of that guy is why can I not find you? I can find H3. I can find H. Where's my H2? I'm blind. There it is. 1.7 times 10 to the negative 5. And then we want the Kb of H2C6H5O7 minus, which is equal to Kw divided by Ka of the conjugate acid. Who is the conjugate acid? That's going to be H3. C6H5O7. This is where people would tend to make a mistake because they've already grabbed a Ka value, yes? We've already got this Ka value, and it's really tempting to just put Kw over that Ka value, but that's the wrong Ka value. It has to be Ka of the conjugate acid. So it's going to be 1 times 10 to the negative 14 divided by, and the H3, C6H5O7, is 7.1 times 10 to the negative 4. And that is 1.4 times 10 to the negative 11. And at that point, we should make a statement that, what should we make a statement that? Ka is greater than Kb. Therefore, the solution is acidic. Now, if this were a written response question, and if you were asked to, it asks you to identify the predominant hydrolysis reaction, you would say, this one here, nope, not that one there. It's the acid one. This one here is the predominant hydrolysis reaction. Are you guys remembering now what the word predominant means? Main. Now, if this were a written response question, you would probably need to write down almost all of this, other than my little teaching annotations. So you wouldn't have to be like, dissociation. Check if each of the ions hydrolyzes. Is the anion amphiprotic? Yes, it has HN negative. You don't need to write that stuff, but everything else, you should actually write the dissociation. You should write the hydrolysis reactions. You should write the Ka, write the Kb, show the calculation, Ka greater than Kb, therefore the solution is acidic, blah, blah, blah. All that stuff would be there. Now, you're not always going to be doing written response questions, so let's make this a little simpler for those occasions where you're doing, say, a multiple choice question. One way to compare the strength of the acid or base is to just approximate your Kb's using powers of 10, okay? So we had done an example yesterday about HCO3. And HCO3, what do we know about HCO3? HCO3 is amphiprotic. And if it's amphiprotic, we would need to know its Ka, and we would need to know its Kb. So its Kb is 1 times 10 to the negative 14. There's our Kw. And that is over, what goes on the bottom to find Kb? Ka. Now, who is it the Ka of? Conjugate acid. So there's going to be H2CO3. Okay, and you can approximate that and you can say, in my head, you wouldn't actually write this down necessarily on multiple choice. You'd just be like, 10 to the negative 14 over 10 to the negative 7 is about 10 to the negative 7. Yes? And then you would look up your Ka of HCO3. Okay, so that's on the chart. And we get a 10 to the negative 11. So we have Ka is about 10 to the negative 11, and Kb is about 10 to the negative 7. So that shows us that Kb is stronger than Ka, and therefore the solution is basic. Another way of doing it involves no calculations even in your head. You're going to just figure out which is stronger by looking at its position on the periodic table. So if we're looking at HCO3, for example, up here it's in purple, okay? And on the acid side, you'll notice that HCO3 is way down near the bottom of the acids. So HCO3 is on the weaker end of the acids. But if we look up HCO3 on the right-hand side, you can see it's kind of in the middle of the list. Yeah? And if it's in the middle of the list, it has a middling strength as a base. Okay? And you know, you would never write this down anywhere, but that's what you can just do in your brain. You can be like middling acid, really weak acid. And so that would mean that, middling base, really weak acid, therefore it is basic. Okay? If we were doing the one we just looked at mathematically, we have our H2C6H5O7. Up here on our bases, right up here is our weakest bases. And so H2C6H5O7 is on the weaker end of the bases. But when it's as an acid, it's kind of in the middle. So it's a middling strength acid, which means, therefore, it is acidic. So if you're doing multiple choice, you can just look at the position and say, really weak, middle, acid. Or you can be like, really weak, middle, or you can be like, high, middle, and just go from there. Okay. In multiple choice questions, you don't always need to write out the dissociation equation to decide the pH of the solution. The more familiar you get with hydrolysis, the more you will simply be able to look at the salt and decide if it is acidic, basic, or neutral. I have been doing this for 35 years. I have no problem doing that unless it's one of the ones where you've got a Ka and a Kb, and I don't know those ones off by heart. But everything else is like super simple, because if you do anything for 35 years, hopefully it becomes super simple, okay? So example number 10, if recall, if neither ion hydrolyzes, If neither ion hydrolyzes, the solution will be neutral and the pH will be 7, okay? So if we look at calcium bromide, calcium is not one of our 4 cations. It's not ammonium. It's not FeAl or Cr. So it does not hydrolyze. For the anion, first of all, we should check, is the anion amphiprotic? Bromide, amphiprotic, yes or no? No, it does not have an H. Now, you can write the hydrolysis equation, or you can simply say its conjugate acid is strong. And if its conjugate acid is strong, it does not hydrolyze. Yes? Probably not unless it was part of like a sort of a multi-part question where it was like, you know, give each of these following salts, classify them from highest pH to lowest pH might happen. Yeah. No. And when you are explaining why calcium is not hydrolyzing, you do not need to explain it. Okay? Do not write out, it's not ammonium or feel creepy. That's just a way of remembering it. Yes? You can just say calcium does not hydrolyze. Bromide does not hydrolyze. Therefore, the solution is neutral. So that would be my explanation. If this were a written question, Br minus does not hydrolyze, and therefore the pH is 7 and the solution is neutral. That would probably be all that you would need to do. Okay? If you cannot immediately see that bromide will not hydrolyze, like it's pretty easy to see that calcium doesn't because it's not ammonium, iron, aluminum, chromium, you can write the potential hydrolysis equation. You can say, okay, in order to check for myself, I'm going to say, okay, I got Br minus. What happens if I put it with H2O? Do I get hydrolysis? Do I? What would I get? I would get HBr and I would get OH minus. And at that point, I look at my acid and I say that acid is strong. What direction would that push any equilibrium? It would push it to the, hold on, maybe your other right? Your other left? Did you mean left?
Well, I was thinking strong goes to completion.
Strong goes to completion, but when it's going to completion, that means it's giving away its hydrogen. Yeah, so that would be the reverse reaction. So it goes to completion, but it goes to completion the wrong way. Yes, for it to hydrolyze, so there will be no hydrolysis. Okay? Now, for example 11, I'm going to add something in here. Will a solution of NH4CN be acidic, basic, or neutral? Justify your answer with calculations. Okay, and if you look at the heading for this, this little section here is when both ions hydrolyze. Okay, so basically what you're going to do is you're going to do what you always do, which is split up the ions. And then you're going to consider each ion individually. Does the cation hydrolyze? Is it one of our four?
Yes.
Yes, it is. And just to make a generalization here, when cations hydrolyze, do we get acidic, basic, or neutral solution? Cations always give us an acidic solution. That means that cations are always going to donate protons. Okay, they always donate protons and they always make H3O plus, which is why most of your cations don't hydrolyze, because they do not have any H plus. Calcium does not have H plus. Barium does not have H plus. But this one does. Whoops. This is still part of step 2. We have to do both our ions here. We ask ourselves, does Cn minus hydrolyze? And if this were a multiple choice question, you could simply ask yourself, is HCN a strong acid or a weak acid? HCN is weak, therefore it will hydrolyze. We'll write this down later, okay? But for now, because we're going to show everything here, we're justifying our answer, we're doing a written response kind of question, we're going to write out the whole thing, okay? So we have Cn minus plus water gives HCN plus OH minus. We should also check to see if the anion is amphiprotic. I forgot to do that. Is it amphiprotic? No. So we don't need to worry about that. Non-amphi, yes, sorry. You should check if it's amphiprotic, because if it's not amphiprotic, it's always going to act as a base.
So but if it's not amphiprotic, the acid is that's all.
Yeah, yeah. Okay, so if not amphiprotic, the anion will produce, it will accept protons and make OH minus if the conjugate acid is weak. That's a lot of words, right? So at some point you want to kind of internalize this, right? So what you do is you check the conjugate acid here. And you say, is it strong or is it weak? It is weak. So yes, we will get hydrolysis. The conjugate acid is weak. So yes, we get hydrolysis. So now we are in a situation where we have made hydronium and we have made hydroxide. Is this solution acidic or basic? You're going to have to compare the Ka and the Kb and decide which one happens more. Okay? So one of the ions makes H3O plus. One makes OH minus. Which one happens more? And that's when you say, I would like to compare my Ka and my Kb. So who am I looking at the Ka for? The Ka I'm looking at is for what substance? NH4 plus. Because that's the thing that is making the hydronium. Yeah? And that one's easy. We just look it up. No calculation involved. Ammonium is 5.6 times 10 to the negative 10. Who will we be looking up the Kb for or calculating the Kb for? Cn minus. Okay, so it is the Cn minus that is making the hydroxide. So we look up the Kb for Cn minus, so we don't look it up, we say that's equal to Kw over Ka, and you should always put something in brackets here. Who are we looking for? The Ka of HCN. Always add a hydrogen for that one, okay? So we have 1.0 times 10 to the negative 14. And HCN 4.9 times 10 to the negative 10. And now we compare 5.6 times 10 to the negative 10 with 2.0 times 10 to the negative 5. I did not leave myself enough room here, but that's okay. Kb is greater than Ka, therefore the solution is basic. Final answer. Yes. Yeah, so if you have both ions that hydrolyze, you're going to compare the Ka to the Kb. If you have an amphiprotic ion, you're going to compare the Ka to the Kb. Okay. I will never give you a cation that hydrolyzes and an amphiprotic anion, because that's just too many things to worry about. Yes? Yeah, so it'll just be, pardon me? Amphiprotic ions, by their nature, they are acids and they are bases. They will always hydrolyze. Yes. Okay? Yes. Yes, this one would be predominant. There's our predominant hydrolysis. How are we feeling? Okay, all right. Here is a summary. This is a summary that you would do if you were doing a written response question. If you're doing a multiple choice, you can cut a lot of corners. Yes? So you would want to write the dissociation equation. You would need to decide if the ions hydrolyze. And so if it's cation, if you have NH4 or feel creepy, then the answer is yes. If the conjugate acid is weak, the answer is yes. Anything else, the answer is no. Okay? Now, the other thing you do need to check is check to see if the anion is amphiprotic. And that means it has an H and a minus. And then you're going to write all the hydrolysis reactions. And by hydrolysis reaction, what two things are reacting? The ion and the water. If the anion was amphiprotic, You're going to calculate its Kb, which is Kw over Ka of the conjugate acid, and you will compare Ka to Kb to determine if it is acidic or basic. Similarly, if both the cation and anion hydrolyze, you will again calculate Kb of the anion, and you will compare Ka with Kb to determine if it is acidic, basic, or neutral. And then you're going to be making a statement, and I actually came up, I realized I should have added something in here, so we're going to add this in. Our statement can be any one of the following, okay? It can be, number one, hydrolysis produced H3O plus. Therefore, the solution is acidic. Number two. Can you guess what number two is? Hydrolysis produced OH minus, and therefore it is basic. Number three. Neither ion hydrolyzed hydrolyzes, therefore it is neutral. And then finally, why do I feel like I had more in the other block? That's okay. You're gonna, if it was amphiprotic, or if both ions hydrolyze, then you'll either say Ka is greater than Kb, therefore acidic, or you will say Kb is greater than Ka, therefore basic. Yes? So now I am going to give you some time to do these 5. Okay? And there's probably not enough room to do all of them, so I'm also going to come around with some paper, extra paper, so that when you run out of room, I don't know, some people managed to do it on there in the last block, but not most of them. So give those a try. There was some whining and complaining about it last block. All 5! And then I asked at the end, and I was like, was it worth doing all 5? And they're like, yes, yes, it was. Because quite frankly, hydrolysis is one of the most poorly done things in Chem 12. So it is worthwhile doing a little bit of practice on it, okay?
Yes. Honestly, there's something every other than and further water. I mean, you're right.
Yes. No, it's so much. It's from the. No, but yeah, it's types around.
That's why it's fancy. It's awesome. Yeah. Yes. It's just the whole time as it goes. So I don't know, I'm not. But if you want to. Like I used to like, yes. Oh, big.
Yeah, you got
Absolutely. Yeah, no, I understand. Totally understand, yeah.
What did you do?
There was a hand up over here somewhere.
Yes. I understand. Oh.
I'm just saying,
Don't solve my.
so I was somebody
It's too complicated.
but I'm not like, if I actually did that.
I mean, see, it makes my brain hurt a little bit because like, I mean, if your amphiprotic one is acidic and your cation hydrolysis, then it's gonna acid for sure.
But if it's basic,
But if it's basic, you have to compare it twice, and then you're like, what proportion of the amphiprotic one is you shake it and start with what one first. It makes my head hurt. Yeah. Yes. Ions don't. Yeah.
they're always,
Yeah.
if this one's only.
It's always. If it's only ion, I don't know. It depends.
Usually it's not easy.
Yeah. 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 And, like stone, right? So this does have, you have an A number, aluminum, so I did it, and then watch where that part actually. But yeah. Right.
That's right, I'm just.
Yeah. Yes,
Nowadays,
correct.
Real.
And then you get to 4 and 5, or those might be a little bit more. Yeah. Yeah.
First thing you didn't know. Just.
Okay, that one is not amphiprotic, so.
Just like a lot of students.
Ironically, release 3, I would say that's associated set right on the hydrolysis reaction. Yeah, yeah. Close for one where only one anion, one ion is hydrolyzing, or if neither of them do, you really can just write acidic, basic, or neutral. If you can see it, you can just write that. And then a written response question might be, and write the hydrolysis reaction. You will need to be able to do that.
His greatest iron. I know my life is this actually you might get around the whole thing. I did not. I know you were going about the first one. Why is it your favorite? Why you know that?
Oh, I'm so sorry. Some child has forgotten that list. Was that you?
What?
What?
Actually, not.
I thought it was one of my grade nines.
I mean, it was. He's not in here. Look at how beautiful she's not.
Because they have pieces everywhere. Everywhere. They're obsessed.
Oh,
Why? Oh, even better, one of the buyers has a penis on it and it says, fucking dispense. Yeah, that's what it says.
It's always like something divine.
Right? I'm like,
There's always
yeah.
sides. There's always like
Yeah.
and
There's a
it's like the
and then there's like, someone touched your awesome, right? And then there's someone like, Lisa.
Bro, we have these
Are you sure? Right? I say, fuck that. Say, no. Right? That's how I feel about that one, right? Like it can be a good punchy sort of thing, but it should not go down somebody.
I know.
Yeah.
It's I don't know. It's when you just go. That is beautiful. Dude, the one. This is what I was
If you get to question number 4 and you're like, what on earth is happening there? If you have feel creepy, you need to remember, so say for example, if we have this one, AlF3, gives Al 3 plus 3 F minus. When you go to hydrolyze the aluminum, do not just write it as aluminum. Remember, for those weird ones, you need to perhaps go to your data booklet and look for the great big long names. So you're going to look for hexaquo iron, hexaquo chromium, hexaquo aluminum. They're those really big, long names. And that will show you exactly what they do. So for example, we are going to not just write Al 3 plus, we're going to write Al H2O6 3 plus.
Oh, right. That's
Now you can figure out what the products are. You can say cations. Cations always give protons. They always donate protons. So we're going to end up with Al. 5 of our waters stay intact. And 1 of our waters has become an OH. But you don't need to remember that because it is also given in the data booklet on the other side of the table. So you can do that whole thing where you get rid of one of the waters and you replace it with an OH. Or you can just look here. Yes? How do I tell if fluoride actually hydrolyzes? It produces a weak acid. And therefore, yes, this happens. So we have now made H3O plus. We've now made OH minus. How do we tell which one is more? We compare the Ka and the Kb. So the Ka
It's loose in the binder.
yes.
Is it the acidic? It always like isn't that acid is always like just the way it works. Association is always much K is much smaller than first. And then you do
But I haven't given you the diprotic acid. I've given you the monoprotic acid. So if we have H2CO3, that's acidic. If I give you NaHCO3, That's basic. Because this is going to give you, this one is always going to give you H3O plus. Yes? And then you can ask, what is that second one doing? But here, there is no second proton, there's only the one proton. Sodium has taken the place of that second proton.
Well, like, into the calculations for amphiprotic acid, or amphiprotic, I know for the permanent hydrolysis for the case when it's just stronger.
Mm-hmm.
The heat, so the acid dissociation is just the Ka of the acid, but the Ke is 1 times 14 divided by a number that's always going to be larger than the Ka of the acid. It's the Ka of one acid, which is much.
But if we go back, hold on. HCO3 is basic. Its Kb is bigger than its Ka. Because you're not comparing the Kb with the Ka of the conjugate acid. You're comparing the Kb of HCO3. Whoa, that was supposed to be a highlight. You're comparing the Kb of HCO3 with the Ka of HCO3. You're not comparing Kb of HCO3 with Ka of H2CO3. You're not comparing those two. Yeah?
I wasn't sure on the numbers of
Like this is you're absolutely right that this, let's do it in pink. This is a bigger number than this. Yes? But that's irrelevant because we're not comparing this number with anything. We're just using it to get this number. And then we compare these two numbers. Yeah? Is that better? Okay. Okay. So, this is as far as I got with the other class. Your homework is going to be how many people have finished the solubility FRQ? Finished solubility FRQ. If you finish the solubility FRQ, I'm going to give you this one. This is the equilibrium and thermodynamics FRQ. And you can do maybe one of these. Is it just you? Anybody else? Okay, there you go. You can choose one or two. Okay? So your homework is number 1, finish solubility FRQ. Second, you're going to finish section 5.1 and 5.2 in preparation for Monday's quiz. On indicators and KB. The Monday is on all of 5.1 So all of indicators. And 5.2, so KB calculations in order to find pH, initial concentration of base, finding the KB, finding KB from Ka. Also, I'll give you the Hebden sections that are relevant as well. I think it's for the quiz, it's Hebden 4.9, 4.15, and 4.17. I can't do these numbers, 4.17. There's not supposed to be anything over top of it. Okie dokie. And if you don't have time to do both of those tonight, pick one. So just go back through 5.1 and 5.2 and see the sections, see the parts you haven't done and do them. Yeah? And if it's like, oh, I haven't done this, but it's super easy, then you don't have to do that part, right? Yeah. We will be doing calculations with hydrolysis. So basically, I give you the salt, and I say, what is the specific pH? So then you need to dissociate, you need to write the hydrolysis equation, and then that's just a KB calculation. Yeah?
I know.